Uh, um, Hi Arjun, are you online? Or you are joined today? Arjun, can you hear me? Am I audible? Yeah, we'll probably wait for another 5 minutes or 2 or 3 minutes and we'll start the class. Today we have a lot of things to cover. Hello, am I audible? Okay, I think people will slowly join us last week. So I'll slowly start today's topics. Or shall I wait 2-3 minutes because only one student has joined? We'll wait for 2-3 minutes, right? Yeah, that's better, right? 6-5 anyway, we'll start. Yeah, I understood. The question is electron flow from where to where, right? Yeah, in a electrolytic cell, what happens? It's a non-spontaneous process. So I also had a doubt in this question. So I went through Google rigorously. I asked a pure chemist. So whatever answer written in that one, the options, the person also told the same. You know why? Because in an electrolytic cell, what we are doing, we are applying a potential and making the process to happen, right? Is that quite clear, right? So what happens? We will connect the negative terminal to the cathode. So at the cathode, electron, what is the density will be higher. So and on the other end, we have anode, which is positive here in electrolytic mode. So electron have a tendency to flow from cathode to anode. Got it? In galvanic cell, it is opposite. Actually, it's spontaneously happening. Hmm? I can't hear you. Yeah. Yeah. Yes. Yes. Hmm. Yes. Yes. Hmm. Yes. Yes, that's correct. But in an electrolytic mm, process, that's a doubt I also had. So when I asked pure chemist, I got an answer whatever the option given in the text, the quiz answer. So I got went through Google properly. So the thing is that so the confusion is between galvanic cell and electrolytic cell. In galvanic cell, galvanic mode means it's a spontaneous process. So we will term anode as negative and cathode, yeah, the same doubt I had, but this is the reason actually. Hmm, hmm. No, actually, the option there is no option like cathode to anode. There is no anode to cathode, right? There is only option cathode to anode through external supply. That's the answer, also, I think, right? Given answer, right? Yeah, this is the reason I went through Quora or many sources. So this is the answer. Like at cathode, we are connecting. Hmm. I went through ChatGPT. ChatGPT gave me the wrong answer. So I asked the professor, I'm from IIT Madras. So this is a sign convention more or like the word electrolytic cell given there, right? In that it is just opposite to that of galvanic mode. That's the main reason we are artificially sending electrons to the electrode. So the electrode is naturally negative. So electron will flow towards positive terminal, right? So because of opposite charge. No, 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 no. No, that is correct. Reaction is correct, but cathode in this case will be electron rich. You see, because negative terminal is connected to cathode. That's right. Cathode is the place where reduction takes place. That's correct. Anode is the place where oxidation takes place. That definition is perfectly correct. Perfectly fine also. But the case is that here in this case, what happens is we are forcing electron to go to cathode. This is the what definition I got because I also thought the option is wrong. Last week you remember, right? Last week I also, you know, mm, mm, which was, I can't hear you. Yes, yes, yes. Mm. Whatever thing you are saying, I am also agreeing. I am also thinking, but the way is the conventional thinking. I think you can write to Professor Ashutosh also. He may can give a better explanation. But I think the option is correct because when I went through literature and I talked to some students because who works on batteries. Hmm. Electron always flow in this direction. Whatever you are saying is correct. But there is a sign convention and the convention in galvanic and electrolytic mode. That's what when I went because many links the answer is giving as you are saying. Hmm? Yeah, yeah. Let me anyway next week. Let me talk to my professor also. I will get back to that question clearly, more clearly. So that will be a better way because he's an expert in this region. So I will ask and get back to you in the next week also. But in the way my friends told as well as some Google links, I am satisfied with the answer given in that option. So I'll give you a better clarification next week. Don't worry about it. Yeah, because we were in a conference last week, so we couldn't meet much, so that I couldn't discuss with him. From IIT Madras, I have a process, so this week probably I'll discuss with him. I'll get you a more convincing answer. Is that fine? Hmm. That's the reason actually that answer also. Yeah, continue. Hmm. Hmm. Yeah, that was little confusing, but no, no, that's not the interpretation. Let's discuss. I'll come up with a page next week because otherwise this discussion will go long. Others will feel what do you say boring. Yeah, yeah, fine. So hello everyone. I think for three of you only joined. So let's start anyway this week's class. 1 second. Can I take 1 second, please? Yeah. So till now we have finished 3 weeks of classes. All of you got opportunity to go through all the 3 week lectures. Only three, but Manju, Dr. Manju, would you able to go through all lectures? Then Dr. Hemalata and Arjun. Okay, have you didn't go through videos? Okay, okay, fine. So what till now we have seen, first week we were seeing Faraday's law, basically. Faraday's law. Second week we were seeing Nernst equation. Also third week Nernst equation only. Then we are progressing towards titration, potentiometric titrations. So let's just rewind what we have seen in week two. But week two, I'm not going very deeply. So for solving problems, we need a set of equations. So first, I will list few equations. Then I want you all to join and try to say the equations. So that way, that's how we can make it more interactive. So first equation we have seen is delta G is equal to what is that equation? Minus N F into E. If it is delta G0, which will be equal to minus NF into E0. So then we have from thermodynamics, we can write delta G is equal to delta H minus T delta S, right? Is it fine? So when we combine this equation 1 and 2, what will we get? We'll get an expression. So we can write delta E is equal to delta H by NF plus T dou E by, sorry, dou E by dou T at constant pressure. How we can, from 2, we can write delta S is equal to minus dou by dou T of delta G at constant pressure. So I also like you all to note down this equation so that we can easily solve the problems. You can also make a small note of these equations. So then what is next? Then we can combine, sorry, we can combine equation number, this is equation number 4. From 2 we will get 4. We can combine equation 4 and equation 1. We will get delta S is equal to, what is that? N F into dou E by dou T at constant pressure. In many problems, we will be asked to find out entropy. In that case, they will be giving a value of d by dt, which have a unit of volt per Kelvin. So please keep in mind this value. Then we can write delta G is equal to, what the another equation we have seen, delta G is equal to minus RT ln Ka. Then sixth equation is E0 is equal to, in terms of log, we can write 2.303 RT by NF ln, not ln, log Ka. Then another equation is E is equal to E0 minus RT by NF sigma nu ln activity. So this 7 equation, I would like all of you to remember these equations. So these equations will be pretty useful in solving problems. So I'll directly come to a question asked in the last class. Why is cell equal to 0 at equilibrium? We have solved a problem, right? Anyone have an answer for this one? Why E cell will take as 0 at equilibrium? So no, that's not any reason. How can? Because I can have a 10 something. Suppose even a redox reaction is happening, reversible reaction. I am doing a CV or something. So if I am having 100 millimolar of A and 10 milli means initially 0 millimolar of B at equilibrium, how can I have equal concentration? It can have, but you have to think little in front. So you, yeah. So it can be related to delta G. At equilibrium, what is the thing? Net rate of forward reaction is equal to net rate of backward reaction. So net rate of reaction is equal to 0. Please remember this. At equilibrium, the rate of reaction is not 0. Rate of forward reaction is equal to rate of backward reaction. So at equilibrium, we can say the net rate of reaction is 0. That is, net work done is also 0. Is it okay? Now we will come back to the definition of what is free energy, Gibbs free energy. Gibbs free energy is nothing but the represent net work done, which includes the electrical and surface work. So by that definition, if the net work is 0, delta G is equal to 0. Delta G 0 means delta G is equal to minus NF into E cell. Implies us E cell equal to 0. Is it fine? W net equal to 0. So you can go back to the thermodynamics textbook. It's there will be I don't know which textbook you're following, but there will be two things. One is Helmholtz free energy. Second one is Gibbs free energy. So the Helmholtz free energy will tell one quantity as well as Gibbs free energy tell another type of work. So if that's related to delta G, E cell, we can say that at equilibrium, E cell is equal to 0. Like that, we at equilibrium, we are taking E cell equal to 0 and solving that problem. Is that clear? Yeah. In such case, so your voice is breaking. Hmm? No, no, standard state is different. So here, free energy will be 0. I think your voice is breaking. I'll continue anyway. Towards the end, we can discuss it again. So what we have, hello? Okay, okay, fine. So you want to first page? Okay. So I'll write it little neatly. Can I change the page? Yeah, this is done also, right? Can I change? Shanti? Okay. So let's get up onto this week's topics. So in this week's content, you can get more both qualitative as well as quantitative questions. Quantitative in the sense calculate the E cell, calculate delta G, those kind of questions. Qualitative in the sense construct the cell consisting of these reactions and write the Nernst equation for the constituents for a particular cell. That those two kind of problems you can expect. What we are, what I'm trying to establish is if a set of anodic and cathodic half cells are given, you should be able to develop the Nernst equation. So I'll just some portions indirectly the assignment questions will be coming. So we'll be solving a set of problem towards the end, but in between also we'll be touching upon some of the problems. It won't be coming as a problem, but still it will be constituting the problems. So for Nernst equation, let's take the example of Daniel cell. Daniel cell. What is Daniel cell? So we have two containers. In one contains ZnSO4, another contains CuSO4. Here, zinc metal is dipped in zinc sulfate, and here we have a voltmeter. We have a copper dipped in copper sulfate solution. So the two compartments we can connect with a salt bridge. So the concept of liquid junction potential, I'll briefly explain the coming portion. So what happens? Here, what is an anodic reaction? I'll write, one of you can tell also, Zn gives Zn 2 plus 2 electron. Then what is cathodic reaction? We have Cu2 plus plus 2 electron gives Cu. So overall reaction we can write overall we have Cu Zn zinc plus Cu2 plus is giving zinc 2 plus Cu. So how will I write Nernst equation in a single stage? So I can write E cell is equal to E0 cell minus RT by NF ln activity of Zn 2 plus divided by activity of Cu 2 plus, where activity of pure Cu is equal to activity of pure Zn I am taking as 1. So this is a right away method. So if I get a reaction, I can write the half cell reactions, and I can, from the half cell reactions, I can write the overall reaction, and from that I can easily write the Nernst equation. So if I'm taking consider half cell reactions only, I want to write the overall cell reaction. How can I write? So you can write Zn. So I'll write it as a reduction reactions. Zn 2 plus 2 electron is giving zinc. Then Cu2 plus 2 electron is giving Cu. What is the half cell reaction here? E Zn is equal to E0. I write it as reduction because I wrote it in the reduction form. Zn minus RT by NF. N is 2 here, so I'll write it as 2. ln of activity of Zn divided by activity of Zn 2 plus. So this I can take it as 1. Similarly, E copper is equal to E0 reduction copper minus RT by 2F ln of, how can I write 1 by activity of Cu 2 plus. Is this clear? I hope it's clear. So from here, we'll have to think one thing very clearly. So whenever we are checking for the standard reduction potential, we have to clearly see whether the potential is written in the oxidation form or reduction form. Suppose for this we know minus 0.76 volt is the standard reduction potential versus SHE. This one 0.34 volt versus SHE. Sometimes people will represent the opposite way. Suppose what happens, Zn gives Zn 2 plus 2 electron. In this case, E0 value will be, oxidation will be equal to plus 0.76 volt. Similarly for copper also the sign will invert if the potential is written in the opposite way. So what is E cell? It is equal to E anode oxidation minus E cathode if it is written in the oxidation form. If it is written in the reduction form, you have to write E cathode reduction form minus E anode reduction form. So this sign convention you have to take care very carefully. Okay. So how can I write the, so here I am representing in the reduction form all the half cell reactions. So I'll be writing E cell is equal to E cathode minus E anode. In order to avoid confusion, I will write both reduction. So both forms, you have to say that sign convention is important. If you take the sign conventions correctly and values correctly, your answer won't change whether you are taking oxidation potential or reduction potential. So how can I write it? It's equal to E0 Cu minus RT by 2F ln of 1 by activity of Cu2 plus minus E0 zinc plus RT by 2F ln of 1 by activity of Zn 2 plus. Is that fine? Is there any confusion? Because sometimes in the classes also I have seen oxidation potential is been taken. In that case, if you Google it, you can clearly see that the reaction will be given in the electrochemical series. The reaction will be given. It will be like Cu giving Cu2 plus 2 electron. In that case, E0 is equal to minus 0.34. If it is written Cu2 plus 2 electron giving Cu, the E0 value will be 0.34 volt versus standard hydrogen electrode. How can I simplify it? E cell is equal to E0 Cu minus E0 Zn. What is this value? 0.34 minus 0.76. It is standard E0 value 1.1 volt versus SH. Okay. Minus RT by 2F ln 1 by activity of Cu2 plus minus RT by 2F ln of activity of Zn 2 plus. Can I write like this? Is it clear how I wrote like this from here? Any doubts? Anyone? So I just took the minus sign out and give that sign here. So it's just rearranged. So it is equal to E0 cell minus RT by 2F ln of activity of Zn2 plus divided by activity of Cu2 plus E cell. For a Daniel cell, we can write like this. So hope all of you are trying with me. Don't copy from me. You can try yourself. If any doubts or if it is checking or any mistake coming, you can directly stop me. So what is that? E cell, E0 cell we can write in many ways. E0 cell is equal to E0 cathode reduction form minus E0 reduction anode, or we can write it as E0 reduction right minus E0 reduction left, or we can write it as E0 oxidation anode minus E0 oxidation cathode, which can be also written as E0 oxidation left minus E0 oxidation right. So this all will give a same value, but the sign convention we are taking will be slightly different. So do anyone want to try it in the oxidation mode and check whether it's coming the same after derivation? Or if everyone is comfortable in this, I will directly move. Anyone want to see how, if I am writing the equations in oxidation mode, how it comes? Or if everyone is comfortable, everyone is clear with this, I'll move on to next part. Anyone? Should I write or shall I move to the next topic? We have so many problems to solve today also. So what should I do? Should I write it in the oxidation form and try to derive the Nernst equation for a Daniel cell, or shall I move? Shanti, Dr. Manchu, Arjun. Is it fine? So shall I move? Okay, fine. So it's in the class problem only. E cell for cadmium solid bar, cadmium 2 plus in aqueous solid bridge, Fe2 plus comma Fe3 plus comma platinum positive negative. So hope from it directly people can write the equation. So here is the left side, right side. So oxidation, reduction. So reduction from how can I write? At cathode CD gives CD2 plus 2 electron. Then at the anode side 2 Fe, cathode side Fe3 plus 2 electron is giving 2 Fe2 plus. The overall reaction will be CD plus 2 Fe3 plus is giving CD2 plus 2 Fe2 plus. So how can I write the Nernst equation? E cell is equal to E0 cell minus RT by 2F ln of activity of CD2 plus into activity of Fe2 plus square divided by activity of Fe3 plus square. I think I wrote it correctly. Yeah. So just try to write these equations every time and try to solve it yourself. So when doing, try to do step by step. Then only we will be having a clear understanding. Next part is the reference electrode part. So as I mentioned in the first class, we cannot measure the potential of a single electrode. So we always represent the potential of a half cell versus some reference, something. In labs, we will use AgCl, and calomel electrode, something. But in the whenever we see the electrochemical series, we'll be seeing something called standard hydrogen electrode. How it represents H2 gas 1 atm, comma platinum bar H plus in the aqueous solution with activity equal to 1. How can I write the Nernst equation for this? So the reaction is half H2 is giving H plus electron. So how can I write? E cell is equal to E0 cell. E0, I'll write it like, it's better to write E H plus bar half H2 is equal to E0 half H2 minus RT by 1F ln of, I'll write it in the reduction form so that it will be easy. Um, okay, it's fine. Activity of H plus. So we know this value is 0. So we can directly write uh, what is say if the activity is equal to 1 also we can write E cell is equal to 0. If activity changes, we will be having a different value. So the next example is calomel electrode. How many of you use this saturated calomel electrode and AgCl? How many are familiar with the electrodes? All of you. How many of you are using these electrodes in lab? Arjun, Shanti, Dr. Manju, so and how many of you are doing electrochemical experiments in labs, or no one is doing electrochemical experiments? Am I audible? Okay, okay. I just want to know how many of you are familiar with these electrodes. Okay, which electrode you are using? Okay, AgCl also you are using. Are you fabricating it or are you ordering it commercial? Ordering, okay. So I'll suggest AgCl and all, we can make it very easily. So in our lab and all, we are making it by buying silverware and glass frits with ceramics. So it's very durable as well as repeatable. So we will make multiple and we will check. Yeah. So what is the reaction? How can I represent the calomel electrode? It's Hg liquid, comma Hg a paste of Hg2Cl2 solid with equilibrium with chloride ion in aqueous. So what's the reaction happening? So overall reaction I'll write as Hg plus Cl minus is giving half Hg2Cl2 plus electron. So I can write the Nernst equation for this, right? So here you can see chlorine ion is there. So you can write the equation on your own. So that's fine. So similarly, AgCl, how is it? AgCl electrode. You can write. So I'm clubbing it with a standard hydrogen electrode, or I'll write it as it is. AgCl plus C electron is giving Ag plus Cl minus. So Nernst equation E cell is equal to E0 Ag plus bar Ag minus RT by F ln of activity of Cl minus. Okay. So here also you can see chlorine. So what is the concentration of KCl we are taking matters. So if I am taking a saturated KCl, there will be a difference of 0.197 volt with SHC. What in my lab I use is 3.5 molar KCl. So there will be we have a correction factor of 0.205 volt or 205 millivolt. As the concentration decreases, it can reach, I think, up to 238 millivolt with different concentration up to 1 molar or 0.1 molar KCl. So like that, in why we are doing this correction is because we need a standard comparison of all the data. So for that, we have to convert it into RHE or SHE before representing in the our papers, and also we'll probably do a conversion to RHE or SHE before the publication now. So for a universal comparison, we'll do that. So these are, I just put the pictures of AgAgCl and saturated calamine electrode. Then now we'll come to electrochemical series. We have seen it is the reduction form. So for Li plus electron giving, so Li plus electron giving Li, we have highest almost negative. So from this series, if you take a combination, we can say which will act as anode, which will act as cathode. If I am taking lithium and aluminum, which will be anode and which will be cathode? Shanti, I am taking lithium and zinc or aluminum. What will be the anode and what will be the cathode? Aluminum will be in ideal case. Always on the class. I'll be asking ideal cases only. Suppose we are taking hydrogen and zinc, which will be anode and which will be cathode. Okay. Okay, let's move on. Then electrochemical series, everyone is familiar. Then next topic we have seen is calculation of activity coefficient. From thermodynamics, we know activity is a product of activity coefficient into mm, concentration. So using that, we will take an example of AgCl plus half H2 is giving Ag plus HCl. So how I can write the cell H2 gas, comma 1 atm, comma Pt solid bar AgCl, comma Ag solid. So how can I write the cell reaction, EMFs? E cell is equal to E0 cell minus RT by F ln. What will be that? I have written in this form activity of H plus into activity of Cl minus. So in this solution, the activity of both, the concentration of both will be comparable. So we can write this as activity plus or minus square. So we'll be substituting back like activity we have written gamma into m. So when we write using the d by Hacker limiting case for a dilute solution also, we can finally write it as E cell is equal E cell plus 0.118. It is after the substitution log m is equal to E0 cell plus Z root m. Z is a integer which is Z is a value constant which is 0.5 for a univalent interaction. From here we can write it as y equal to mx plus c. No, activity is not. This is actually what happened. The what is it? The it is a solution. It is a neutralized form. So we will take it as activity will be equal. So that's why we are taking the, for a dilute solution, we are taking that limiting case. Then we are deriving this expression. So what will be the plot? It will be y, then root m will plot. The intercept will be giving E0 cell. Then the slope will be giving z. So like that, we can calculate the E cell as well as the activity coefficient. So we have the z and root m. If we get, we can back substitute in the equation. which was that equation I have mentioned, which is log gamma plus or minus is equal to minus z root m. Okay, so we can get the activity coefficient. Similarly, the next topic was a very interesting topic, liquid junction potential. So I was when I was attending the classes, this topic my faculty used to ask funny questions. So what is liquid junction potential? So as we all know, different ions have different ionic mobility. Suppose we take H plus, we have K plus, we have Cl minus. These all have different ionic mobility. So suppose I have a container which is separated by a mm, separating wall, suppose. So I have KCl solution here, or KCl rather, it's better to say HCl solution here of concentration C1, and HCl solution of concentration C2 and C2 greater than C1. Suppose I am removing the barrier at a time t greater than 0. What happens? At the junction, solution always have the tendency to move from the higher concentration region to the lower concentration region. So it will try to migrate in this direction. So what happened? H plus, which is having a higher ionic mobility, try to move faster compared to chlorine. So what happens? When a charge is separated by a distance, we have an electric field there, which will produces a electric potential. This potential will act opposite to the potential of the galvanic potential, we'll say galvanic potential. So this is something like undesired in the cells. That's why we are using salt bridge. This liquid junction potential will be depending of one term called ionic mobility. Ionic mobility. So when we write lambda m, how can I write? Lambda m h plus, sorry, lambda m I don't write. Lambda h plus is to lambda k plus is to lambda cl minus will be equal to 350 is to 76 is to 74. So you can see that why hydrogen is moving faster, because it have a higher ionic mobility compared to KCl and K plus and Cl minus. Now you can tell an answer why we are using KCl like material in salt bridge. Any of you? Why we are using KCl in salt bridge? Yeah, because the ionic mobility of K plus and Cl minus is comparable, so that the liquid junction potential won't be developed. So if liquid junction potential develops, we cannot measure liquid junction potential. That's the part. It will reduce the cell potential, but we won't be knowing that. So we, in every case, we'll be trying to minimize the liquid junction potential. In experimental cases, we might be adding something called supporting electrolyte. So this will try to eliminate these problems. So in this case, we have seen two type of this one. One is amalgam cell, and second one is concentration, electrolyte concentration cell, electrolyte concentration cell. In these both cases, there won't be any potential due to the Faraday reaction, but the concentration, the EMF developed will be because of the liquid junction potential. So, since we have a lot of problem to solve, I am not going to potentiometric titrations in this class. That was the last topic covered in this week's lecture. Anyway, that topics is continuing in the next class or next week lectures also. So now we will start our problems. So there was many homework or problems on the class. We will start from that and we will solve some more problems. So question number one: calculate the by the way, I think last class there was a homework which was given in week two. Last week someone was asking. I hope everyone got the answer for that question. In the third week lecture, it was solved for that HCl problem. So the value of E cell was given in that problem. That was making confusion. E cell value was 1.01 something. We don't need to use that value. Actually, we have chlorine elution potential, which is something around 1.36 volt, which we will get from literature. We can use that value to calculate Sorry, E0. E0 cell. From E0 cell, we can directly calculate the free energy. So I think that problem was solved in class. That's why last class I didn't solve that problem. It was solved in the third week lectures. So if someone having seen that problem, please go through it. Mm, if any doubt, we can clarify in the next class. So calculate the potential. Oh, sorry, potential of following electrodes electrodes at 25 degrees centigrade. So first one is Ag bar Ag plus with activity of 10 raised to minus 5. How can we calculate? It is solved in class, but there is a mistake, I think. So that's why I'm telling all of you to solve it again. I'll give the E0 value. E0 value is not given in the problem. E0 is equal to 0.8 volt versus Ag AgCl. So can all of you try to solve this problem? The reaction is Ag plus electron is giving Ag. Can you try to solve it using Nernst equation? As before, if someone is finishing, just put it done. Then we will solve. Anyone? Are you able to follow the problem, or shall I do the first one for all of you? Then we have few more questions like this, so we'll solve those things together. What? Can I? Yeah, yeah, fine, fine. That's fair enough. So E cell is equal to E0 cell minus RT by NF ln of activity, right? Sigma ln activity. So how can I write is equal to 0.8? Its value is given 0.8 minus, it's a single electron process. RT by F ln of, I have written it in the reduction form. So activity of Ag divided by activity of Ag plus this in the solid form. So I will take it as 1. So we can write E cell is equal to 0.8 minus, I can write, I will rearrange it as using, I will convert ln into log so that I can write 0.0591 log of 1 by 10 raised to minus 5, which can be rewritten as 0.8 minus 0.0591 log of 10 raised to 5. So how can I write? It will be log 10 is 1. It will be multiplied by 5 will be multiplied by 0.0591, which is equal to 0.8 minus some value will come. So you can write that. You can calculate that. The answer will be, which is equal to 0.5045 volt versus SHE. Is it fine? Yeah. So we'll move on to next question. 1 second. I'll take it. Please. Yeah. So the second question is Cu bar Cu2 plus, where activity is equal to 0.24 Cu2 plus. So E0, you all know that value E0 Cu bar Cu2 plus bar Cu is equal to 0.34 volt versus SHE. So can you try to solve this? Always try to write the half cell reaction first, either in the oxidation or reduction form. Then try to solve it. I think you missed a minus sign. The reaction will be Cu2 plus 2 electrons. Yeah, Cu. How can I write the Nernst equation? E cell is equal to 0.34 minus RT by F 2F ln of 1 by activity of Cu2 plus equal to 0.34 minus 0.0591 divided by 2 log of 1 by 0.2 will be 5. No, it will be. Is it clear? Is equal to 0.3193 volt versus SHE. Is it clear to everyone? Shall we move to next question? Yeah. Next question is PT comma PT bar Fe2 plus comma Fe3 plus, where activity of Fe2 plus is A is equal to 0.1 and activity of Fe3 plus is A is equal to 0.01. Fe3 plus electron is giving Fe2 plus, where E0 Fe3 plus bar Fe2 plus is equal to 0.77 volt versus SHE. So here in class problems and all, the value of E0 may not be giving, but in exams, I hope it will be given. Once solved, let me know. Yeah, you just comment done. Once we will give opportunity to others also. What's the answer? Anyway, you told 0.7109, right? Yeah. So how can we write 0.77 minus 0.0591 log of activity of Fe2 plus divided by activity of Fe3 plus. So both values are given equal to 0.77 log 10. It is directly coming. So 1 electron process. So minus 0.059. So the value will be 0.7109 volt versus SH. So number 3 was, so it was also direct. So now we move on to little more problems. Yeah. So question number 4. So I will try to solve three problems. Here the question is construct the electrochemical cell for a for the following reaction and find the standard free energy change from EMF. So first problem, there were three problems. One was solved in the class, so I won't go into that problem. So I'll just write what was that. Half Cl2 plus Br minus was reversibly giving half Br plus Cl minus. The value was calculated as delta G is equal to minus 28.35 kilojoule. Someone asked anything? Fine. This problem was clear to everyone, right? So I hope everyone went through the class lectures. So we'll go to the next problem. B Hg2Cl2 reversibly giving 2Hg plus Cl2. First you have to construct the cell, then you have to write the uh, you have to find out the E0 value from the literature or internet. Then we have to solve it for delta G. That's the strategy we have to use. Standard give free energy only told, so E0 cell will be sufficient for that value. So first write anode reaction and cathode reaction. So I'll give 2 minutes, then we'll discuss that reaction. Then further we'll move. Are you all able to write the anode and cathodic reactions? What is the reaction at anode? So here if you see, this is 2 plus, this is minus, this is 0, this is 0. So it is getting reduced, uh, reduced. This is getting oxidized. So what is the reaction at anode? Anyone? What might be the reaction at anode? It's an oxidation reaction. So chlorine is getting oxidized here. So what will be the reaction? Anyone? Yeah, it can be written as 2Cl minus is giving Cl2 plus 2 electron. What will be the cathodic reaction? Yeah, continue. Yeah, mercury plus chlorine ion. 2Hg plus 2Cl minus. So I'll just write an overall reaction. So I'll get Hg2Cl2 is giving 2Hg plus Cl2, right? We got the same equation. So how will I represent the cell? I can write it as PT solid bar Cl minus aqueous bar Hg 2 plus bar Hg. So can you, I will give the E0 value. E0 reduction for Cl2 plus Cl minus is equal to 1.36 volt. Then E0 reduction for Cl2, sorry, or next one is Hg2 plus, okay. Hg2 2 plus bar Hg is equal to oxidation versus reduction value equal to 0.79 volt. So E cell is equal to E cathode minus E anode. So which is equal to minus 0.79 minus, sorry, 0.79 minus 1.36, which will be equal to 0.57. Fine. Is it okay? So now I want delta G0 minus NF into, yeah, yeah. E0 S? Yes, yes. What? I didn't get it. Hmm? Yes, yes. Hmm. Hmm. That is reduction, right? Hmm. Reduction only. Minus 0. Cathode, E cathode minus E anode. So E0, I should write E0, E0. Yeah, I have written. That's the one in the lectures professor is taking like oxidation potential and doing. So the value will be entirely just different. Like, yeah. So minus NFE0. So how many electrons are there? Minus 2 into 96485 into E0 value is minus 0.57. What is the value? Someone finish the calculation and let me know. I'm writing it fast. If you are not being able to read something, just let me know. There is no problem in that. If you are not being able to read some numbers or something, please feel free to tell that. Is it done? What's the answer? Yeah, we can write it as 109.9. Always try to write in short form. So kilo joule. I hope everyone got it. Anyone have a doubt? So we'll go to problem number C in this section. So similar question. H2 plus Cu2 plus is reversibly giving Cu plus 2H plus. So what is anodic and what is cathodic? First, let's write that and we'll proceed to solve this problem. So what is the anodic reaction here? Which is getting oxidized. Yeah, here hydrogen is 0. It is getting to +1 form. So hydrogen is oxidizing. Then Cu is getting reduced. So what will be the anodic reaction? Anyone? Can you rethink because hydrogen is oxidizing. So it will H2 gives 2H plus 2 electron. Yeah. What will be the cathodic reaction? It's very simple. So I expect very fast. Cu2 plus 2 electron gives Cu. Yeah. So E0 values you all know, right? E0 for Cu2 plus bar Cu. What is that value? 0.34 volt versus SHE. For hydrogen, it is, what is the value? H plus bar H2. Yeah. Is 0. So can you calculate delta G? Delta G 0. E0 is equal to, what's the value coming? Minus 2 into 96485 into 0.34. So answer will be minus something. I want the answer in kilojoules. Hmm. Yeah, I got 65 point, yeah, 61 kilojoules. Yeah, we have how many questions is it for? We have 6 more questions to. Let's move little faster. What's the time? 7:10. Okay, let's move little faster. So next question is, wait. Yeah, this is actually, we don't need to think that much. It's delta G negative means the reaction is feasible. Delta G positive is reaction is not feasible. So it's just a equation. We are not writing like a practical thing, right? We are just writing a reaction. From the reaction, what is oxidizing, what is reducing. So you can see here from the, where is the table? Yeah, do we have chlorine here? So we don't have chlorine. So if we sometimes if we check when solving some problem and checking just to electrochemical series, the value may not be matching. So that reaction is not thermodynamically feasible. That's the thing when delta G is positive. But delta G positive still we can achieve it in some conditions. That's also you just think. Like we cannot convert CO2 in room temperature without applying anything, right? Or water we cannot split into hydrogen and oxygen on its own. When we apply potential, it is happening. So like that you can think it is not a practically derived problem, it is just a numerical problem. So delta G can be positive or negative. So in this problem, we don't have any significance in that, but generally when we say delta G negative means it's thermodynamically feasible, delta G positive means it's infeasible. So sorry, are you fine? Yeah, it's just a numerical problem. Can we write next question? If the potential of Zn bar zinc chloride of M is equal to 0.01 bar AgCl solid comma Ag is 1.16 volt. Calculate the ionic activity of ZnCl2 solution. Is it clear, question? Please try to solve it here. If the potential of zinc bar zinc chloride uh, m equal to 0.01 bar AgCl solid comma Ag is 1.16, I think 1.16 volt, calculate the ionic activity of zinc chloride solution. So always anode reaction you write, cathode reaction. What will be the anodic reaction here? Yeah, we can write 10 please. Zinc 2 plus 2 electron. What will be the cathodic reaction? You think about what's happening in AgAgCl reference electrode. We have seen it 2-3 times. So what will be the cathodic reaction? No, because we have chlorine ion also here. We have to balance the equation also. So the reaction will be AgCl plus 2 electron is giving Ag to Ag plus Cl minus. Sorry, 2 Cl minus. So can you try to solve the Nernst equation? So what will be the overall reaction? So it will be easy to solve. Zinc plus 2AgCl gives zinc 2 plus 2Ag plus 2, sorry, Cl minus. Yeah, we can write it in another way, which will give 2Ag plus zinc chloride. So I will give two values also, E0 for zinc plus Rc is equals minus 0.7621 SHG. Then E0 value for what is that other one? Ag bar Ag plus. Ag is equal to 0.22. Is it done? So I can write E cell equal to E0 cell minus RT by 2F ln of activity of 7Ca2. Now I can substitute the values. Just substitute and get the solution. Activity of zinc chloride. finished. What's the value of activity of second Cl2 coming? Are you able to follow, all of you? So you can calculate it 1.06 into 10 raised to 6. Just need to rearrange. You can either convert it to log or you can follow it in ln itself. Okay, is it okay? Shall we move on to next question? This is little interesting. So we have to go back to, yeah. Any problem in this question? Yeah. Inner cell will be 0.222 minus 0.76. It will be 0.982 volt versus SHE. Yes, because I have given reduction potential only, right? Yeah, I think it's a direct substitution. Yeah. Okay. Shall we move to next question? So consider anyone one more time, or shall we move to next question? So okay, consider the cell TL bar TL CL solid bar KCl 0.1 bar Hg 2Cl2 comma Hg solid. Here given E cell is equal to 0.73 and dE by dt is equal to 7.5 into 10 raised to minus 4 volt per Kelvin. So what is the cell reaction? Cell reaction and also calculate delta G and delta H of the reaction. So question is, we are given with a cell, so we'll write it as positive and negative. We have given with E cell as well as a value dE by dt. So from that, we are asked to calculate. First, we have to write what is a cell reaction. Then we have to calculate delta G and delta H values. Is the question clear? So, I won't write here. Right. Anode, cathode, anode reaction, cathode. What will be the anode reaction? Can anyone try? What will be the anode reaction? Which species will be oxidized here? Anyone? TL. So how can I write the reaction? 2TL is giving 2TL plus 2 electron. Cathode reaction is straightforward. Anyone? We have seen the calomel electrode reaction. So what is that? Hg2Cl2 plus 2 electron will be giving 2Hg plus 2Cl minus. So what will be the overall reaction? 2Tl plus Hg2Cl2 is giving 2Tl plus 2Hg plus 2Cl minus. So I'll just rewrite it a little. So how can I write? 2Tl plus Hg2Cl2 will be giving 2TlCl plus 2Hg. Now I think the values of E cell is given. So let's calculate delta G as well as delta H. In the starting, that's why I have written all the equation in the starting of the class. Just go back to the pages and write the equation for delta G and delta H and calculate. What is the delta G value coming? What is the equation for delta G? What is the equation for delta G? Delta G is equal to anyone? Minus NFE. Yeah. So calculate E value E cell is given. So just substitute. It's a 2 electron process. Delta G is equal to minus 2 into 96485 into 0.73. Answer will be minus 140.87 kilojoule. Correct. Now calculate delta H. For that, what's the equation? We have already written E is equal to minus delta H by NF, right? NF plus T into dou by, dou by dou T of E at P. So all the values are not. Dou E by dou T at P is not. We know E also. So just direct one again. N also non 2, F non. T is you can write 298 Kelvin. So what is delta H? What's the answer coming? Delta H? It's minus 97.74 kilojoule. Is it- I hope everyone got. Anyone have doubt to the calculation? So let's move on to next question. Q. Yeah. Hmm. 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 Which one? Here. Yeah. Hmm. Yeah. Here THL2 square term will come. Yes. Yeah. In this problem, it's not asked. That's why I didn't write. 298, 298. Since it's not given, we will take 298. If in the problem it's given specific, here also we some sort of you will take room temperature 25. 298 you can take. Since it's not specifically given any temperature right in the problem. So in that case, always take 298 and do the calculation. Shall we go to next question? What was the question number 6? Now question number 7. So here what was our question? Write the cell. So what kind of reaction is this? What is this kind of reaction called? Here it is getting reduced. Here it is getting oxidized. In the same equation, it is getting oxidized and reduced. What is this type of reaction called? Anyone? It is disproportionation reaction. No, redox reaction is fine. It's specifically called disproportionation reactions. In the same equation, it is getting, it's a redox couple, we'll say, but this kind of equations are specifically called disproportionation reaction. So what will be the Nernst equation? E cell is equal to E0 cell minus RT by F ln of activity of indium plus to the power 3 divided by activity of indium 3 plus. So I am taking activity of indium to be 1. So I'll just give a set of standard values. Indium 3 plus 3 electron gives indium. So its potential is minus 0.34 volt versus SHE. Then second one is indium 3 plus 2 electron giving indium plus, which is minus 0.44 volt versus SHE. The third one is indium 3 plus electron giving indium. So it's having a minus 0.14 volt versus SHE. So here this cell can be minus 0.44 minus 0.14, which is equal to 0.3 volt. What happening? Indium 3 plus is given to indium plus, then indium plus is here, indium 0 is giving indium plus. Yeah, is it fine? Shall we move to the next question? QH into 1 second. The calculate the equilibrium constant for the reaction to Fe3 plus SN2 plus is basically giving 2 Fe2 plus SN4 plus given E0 Fe3 plus is equal to 0.75 volt E0 SN, oh sorry, SN4 plus bar SN2 plus is equal to 0.15 volt. What's the equation we have to use here? E0 is equal to 2.303 RT by NF log KA, capital K. So from this we can calculate. So here what will be the E0 value? E0 is equal to what? What's the E0 value? By the way, which will be cathode, which will be anode? Hmm. Reduction, oxidation. So how will I write? E0 cell is equal to 0.75 minus 0.15, nothing but 0.6. So E0 is equal to 0.6 implies us I can write Ka is equal to what? This entire value, which, yeah, this portion, how can I write this? What is the value at standard state? That is 25 degrees centigrade. Yeah, to 25 degrees centigrade, what will 591? So direct substitute, then we'll get the value of K. Yeah, I have written log only. I have written log. Yes, yes. Actually, 2.303 into R into T divided by F. That value is 0. It's log. Otherwise, if 2.303 is not the, it will be ln. So we are converting between log and ln, natural log. Yeah. Yeah, answer is coming. Ka is equal to 2.02. This is the answer I got into 10 raised to 20. What about others? Are you all getting this answer? Shanti, Sri. Yeah, sure. No problem. So what we'll do? So we have E0 is equal to 2.303 RT by NF log of Ka, right? What is the number of electrons involved here? Can you say how many electrons are involved in this? Two. Yeah. So we already have the value 2.303 into 8.314 into 298 divided by 96485. What's the value? 0.0591. Okay. So E0 we have calculated. What the value came? 0.6. 0.6 is equal to 0.0591 divided by 2 log Ka. Is it fine? So we can write log Ka is equal to 0.6 into 2. I am writing 1.2 divided by 0.0591 log, yeah, 91. So Ka, since it is log to the base 10, we have to write Ka is equal to 10 to the power 1.2 divided by 0.0591. So this value will come like 2.02 into 10 raised to 20. Now is it fine? Yeah. So this always try to remember this value and substitute it directly. So it will save your time. Well, wait 1 minute. So if someone want to write, let them finish. Okay, shall we move to next problem? Okay, I'm moving to next problem. Question number 9 for day. The standard electrode potential. The standard E0 of Fe3 plus or Fe2 plus and Fe plus Fe2 plus bar Fe. Sorry, I'll rewrite it clearly. Fe2 plus bar Fe are 0.77 and minus 0.44 volt versus SHE at 298 Kelvin. Calculate E0 for Fe3 plus bar Fe. Is it clear question? Anyone able to formulate the idea or shall I give some hint? Shall I give some hint, or are everyone solving? Anyway, I'll give a hint. So here it's given Fe3 plus gives Fe2 plus, which gives Fe. This is n equal to 1, 1 electron process, n equal to 2. They're given 0.77 minus 0.44. So what we are asked to solve is this, which is n equal to 3. So what is the value? How can we write? I will give one more hint. Delta G is a state function. We're able to solve, everyone. Any doubts, or shall I solve? Shanti, Ganga, Arjun. Yeah, fine. So what's the equation? Delta G is equal to minus NFE. Since delta G is a state function, it will be depending upon the initial and final state. So we can write minus 3 into F into delta, sorry, not delta, sorry, E Fe 3 plus bar Fe will be equal to 1 in minus 1 into F into E Fe3 plus bar Fe2 plus minus, it is plus actually, plus minus 2 into F into E Fe2 plus bar Fe. So F will cancel out everywhere. So now I think all of you can solve. Can you try to substitute and find the value? So 3 E0 Fe3 plus bar Fe will be equal to minus 3. Did I put minus here? Yeah. Minus 1 into E Fe3 plus bar Fe2 plus minus 2. It will be the E0 Fe2 plus bar Fe. So values are given. This value, what's the value? 0.77, I think. This value minus 0.44. Minus 0.77 plus 0.88. So E0 Fe3 plus bar Fe will be equal to minus 0.036 volt versus SHE. Clear? Okay. This type of problems, all of you try to solve. It will be available in internet, so it will be useful. Maybe you can expect this kind of questions in final exam also, I guess. This kind of question we should always like, because this applies our basic concepts to the problem, rather than there was no equation directly linking that, but our concept is getting applied. So last question, it is very simple question. So I just prepared it just before the class. So consider the cell Ag solid where AgCl solid, comma HCl 0.1 normal, KCl 0.1 normal. Sorry, I'm writing the next line, comma Ag bar AgCl solid. The potential developed in this cell is dash. What is the potential developed in this case? What will we call that thing? Everyone, it's a single word answer. Will there be any galvanic potential between these two? You see, anode is same, cathode is same, both in chloride ion. So, will there any, if I connect a voltmeter, what will be the voltmeter reading? Anyone? Answer is correct, but the potential developed is, we will call it a specific potential. What is that potential? It is not galvanic potential as we. Hmm? Arjun, can you repeat? Can you repeat what was the answer you told? What will your potential develop? Liquid junction potential. Yes, LJP. Why? You see, everything is same here. Even concentration is same. But here it is HCl, here it is KCl. So as we already seen, hydrogen have 350 higher ionic mobility compared to potassium. I think it's 76 or something, 76 or 74. So the potential here will be the liquid junction potential. So there won't be any galvanic potential. So that's why I wanted to put it here. So just see here, only the liquid in which it's is different. Not even liquid, the anions are same, but the cation is different. Since the ionic mobility of cations are different, there will be a potential developed at the interface, which is called liquid junction potential. Okay. Okay, that's all for today. So how is the pace actually? Whether should I come for more problems or a mixture of what taught in the class for the week and for some time and problems? Which composition you all of you like? If you give suggestion means I can improve in the next class according. Okay. Okay, okay. What about others? More problems or little what seen in the week than problems or more problems like 10-15 minutes or 20-30 minutes maximum this one and little more problems what you all like. Okay, so today I think I went little longer because I when I was preparing I thought like if I go for the last lectures it will be too longer, I can't solve 10 problems. That point I cut down the that potentiometric titration portion and came to the problems. So I'll try to do this way. We'll try to do the theory part maximum for 40 minutes. Then after that, 1 hour, more than 1 hour, we'll be trying to solve the problems. Is that fine? Composition, Shanti, others? If someone is strong in theory means they can just join after like 6:30. That's also fine for me. Yeah. So we'll follow today's pattern itself. So we'll try to solve more problems. If time permits, we'll solve more problems or we'll try at least 7 to 10 problems every class. Then we will refresh what all things go have been taken by the professor in that week. Okay, then thank you everyone for joining. So hope the sessions are useful for you. Thank you. Bye. Yeah, yeah. Yeah, it is last week also it shared. I think in the NPTEL portal itself, they have made a link where you can don't try to access the attendance. Attendance also it's there. That's fine. There are two things. One is class notes plus the video will be uploaded in the YouTube. The same video we are asked to upload in YouTube and share the link. So both things every week, same link you can access and take that. Today itself, by today night itself, I'll be uploading everything. Yeah, fine. Okay, then bye. See you next week. Yeah, bye.